Esteemed session speaker, Dr. Orun Chakraborty, respected session chair, Dr. Sharodaya De, respected faculty members, invited guests, conference participants, and fellow students. Wish you a very good morning and welcome to the pre-lunch session of the International Conference for Climate Change, Global Cooperation, organized by St. Xavier's College, Autonomous, Kolkata. As I speak, I am reminded of a thought by Mr. Robert Swan, which hasn't left me ever since. The greatest threat to our planet is the belief that someone else will save it. Today, as we gather here for this momentous conference, we are not only talking about awareness, but calling for action. Awareness that triggers action, action that has the power to bring about change. It is with immense pleasure that I introduce our chairperson for the current session, Dr. Sharodaya De. Dr. Sharodaya De is presently working as an assistant professor in the Department of Environmental Studies in St. Xavier's College, Autonomous, Kolkata. She received her BSc in Chemistry from St. Xavier's College, Autonomous, Kolkata, and MSc in Atmospheric Science from Baligan Science College, University of Calcutta, India. She has completed her PhD from the University of Burdwan and also worked as a postdoctoral researcher in University of KwaZulu, Natal, South Africa. Her research interest is to explore and understand air quality, climate change, and their health impacts. She has published 5 research papers in international peer-reviewed journals and 2 book chapters. She has presented her research papers in 6 national international conferences and made 2 conference publications. She is presently working in an Indo-Poland joint project sanctioned by DST, International Cooperation Division, Government of India. She has won the Young Scientist Award at 2nd International Conference on Mother Earth, Save It to Achieve a Sustainable Future for All, in 2014, organized by the Department of Environmental Science, University of Burdwan, India, and Best Paper Presentation Award at 2nd World Clean Environmental Summit in Science City, Kolkata in 2018. We will now felicitate the chairperson, Dr. Sharodaya De, with a token of appreciation. Ma'am, We would now request you to kindly introduce our esteemed speaker for this session, Dr. Orun Chakraborty.
Good morning. First of all, let me thank Xavier and Janvi. Actually, we are very happy and privileged to have Professor Orun Chakraborty serve with us today. First, let me introduce him. He is an eminent researcher and academician from IIT Kharagpur. Dr. Orun Chakraborty is the professor in the Center for Ocean, River, Atmosphere and Land Sciences, Coral, IIT Kharagpur, Indian Institute of Technology, Kharagpur. He is working in the area of regional ocean modeling and basin-scale ocean atmosphere coupled model for almost 22 years. He is one of the leaders of regional ocean modeling and expert in the basin-scale coupled modeler in the country. He is one of the fellow of Royal Meteorological Society, UK. He is also a member of many academic and research societies. Professor Chakraborty, besides teaching, also motivate, mentor, guide, and inculcate values and help students in their research and academic activities. He is one of the lovable teachers also in his department. His main research contributions are Regional Ocean Modeling System, what we call is ROMS, R-O-M-S, application for Bay of Bengal. He is especially working on Bay of Bengal, the changes in the ocean currents and climate change association with air quality and water interaction, this coupled modeling system. And he has explored the mechanism of western boundary currents discontinuity of Bay of Bengal during Indian summer monsoon, impact of river discharge to the circulation of Bay of Bengal, introduction of objective analysis technique to improve the synoptic initial condition for the model for this particular region of Bay of Bengal. He has been working on oceanic heat content and cyclone movement, which is also one very important topic these days as we are facing more and more frequent as well as severe cyclones these days. Seasonal and interannual variability of sensible heat flux over Bay of Bengal. He has been studying these. Under his guidance, his students are also doing active research in these areas. Professor Chakraborty has guided till now 20 PhD students, 3 MS students, 1 dual degree MSc student, and 32 MTech students. He has published 92 papers in reputed national and international journals. Besides the academic accomplishment, Dr. Chakraborty has also served as the head of the Department of Coral for 4 years, and he is also actively involved in many academic activities. So all we can say here, we are honored, we are privileged to have Sir here with us today in this international conference on climate change, global cooperation, organized by St. Xavier's College, Autonomous, Kolkata. And we are looking forward, we will love to see the presentation and the expertise Sir has. He will be sharing with us, and I'm very sure that students and researchers, all who are present, they will be benefited, they will be enriched with his presentation. So I would like to welcome Sir, and we are grateful to Sir that he has given his valuable time here, and he is here to present his ideas and innovations.
We would request Dr. Sharodya De to felicitate our honorable speaker, Dr. Orun Chakraborty. Thank you. I would like to hand over the proceedings to Dr. Sharodya De as she steers the session forward.
Now, may I request, Sir, to give your innovations and ideas and enrich us, and we will be very happy to see your presentation as well as your lecture, Sir. Sir, please.
Thank you very much, Dr. Sharodya, for nice introduction. And very, very good morning to all of you. So today morning you have heard about climate change and climate variations and its impact on the environment. And now I am going to talk about the physics of climate change. Basically in descriptive climatology, whatever the data record is available, so generally analyzed those data and we talk about the variations. Now, if we want to extrapolate, then we need the model which we call kind of coupled model. Model means numerical model that requires the understanding of mathematics and physics. And that model we are using in the different system, that is our Earth climate system, we called. There are a lot of interactions and nonlinear interactions. So this is very complex to understand. And whatever the model till now that developed by many researchers across the world, there are many demerits, needs improvement, and needs the proper understanding of the physics. So people are working on that. Today I am going to talk on that aspects, because if we start only ocean modeling differential equations, then like your students and researchers, those who are present here, that will be like you're not digestible. And so I thought that your physics of climate change will be a good one to discuss. Now, this climate change and climate variations, when this word comes, then we need to know about the climate system, the definition of climate system. And this is a common definition, the complicated system consisting of various components, including the dynamics and composition of the atmosphere, the ocean, the biosphere, the ice and snow cover, the land surface and its features, the many mutual interactions between them, and the large variety of physical, chemical, and biological processes taking place in and among these components. So these physical processes, dynamics, and kind of thermodynamics playing role that needs understanding, because the main drive of this climate system is sun's radiations. It comes from there. So that drives this whole system. That energy is coming from the sun, and that all we know. And climate refers to the state of the climate system as a whole, including a statistical descriptions of its variations. And then how much we are telling something maybe mean and how much it is varying from our results, statistical way we are doing. Now, if we, as in the morning, the discussion was that lots of things happening in the nature, sea level rise, your number of heat waves, and your number of deaths, flash floods, then your landslides, tropical cyclones, all are increasing. Now, severe tropical cyclone also increasing. And also, like your monsoon, that is also abrupt. Why all these things happening? Scientists are questioning and trying to find out that the physics behind it, and then understanding of that physics, how to include in the model such that better predictions we can do. So as the nature of the Earth system, we are talking here climate of the Earth. So this is, Earth system is consists of 5 major components: lithosphere, biosphere, cryosphere, atmosphere, and hydrosphere. That hydrosphere is ocean plus ice cap regions. Now out of that, atmosphere and your ocean, that is your well understood, and you can model. Still there are like your mostly like your physics understood in the in this Earth system. But biosphere, lithosphere, and cryosphere dynamics and thermodynamics is very, very difficult. So that has been started late to understand. We don't have that much of data at different regions. So lots of improvement is required to get the accurate climate data for predictions for the future. Now, these 5 components, they are interactive in nature. And interactive, this is your complex way, and also cascading in nature. Cascading, like one is linked with the others. So this is very, very complex, and that complex things we want to understand. And another thing that this subsystem, this is nothing but the thermodynamical systems. And that thermodynamical system that governed by some fundamental laws of physics. And that fundamental laws of physics that we apply to this system, and also same time this, when we talk about atmosphere and ocean, these two are fluid. So this fluid, its motion in not only in inertial frame, but this is non-inertial frame because Earth is rotating. So it is very crucial to understand those fundamental laws in rotating frame. So that is very, very difficult, and at the same time in the spherical coordinate systems, because Earth is almost like a sphere. And also we should understand this feedback mechanism. So for like your schematically, we can express like this. This left-hand side figure, this is your whole system, that ABC is our maybe atmosphere, hydrosphere, lithosphere, all those systems. And the solid line, that is the surroundings. So with solid line, that is the boundary wall, obviously imaginary. So through that, there are interactions with the surroundings. That means exchange of properties, that may be mass, energy, and momentum, that your exchange takes place. How that mass, momentum, and energy, that transfer, that understanding also difficult, although we parameterized it as per our understanding, but needs improvement. Now, in between, like from one subsystem to the other subsystem, so their interaction, exchange of those properties. I am writing here as X. X may be anything, that may be mass, energy, or momentum. So that exchange takes place. And also, this environment, this is act as a feedback system. Feedback systems in electrical engineering, we have learned that any input, if we give to the system, then you will get some output. If suppose output and input, they are same, then that system's gain will be 1. That is your output by input. And in this case, like if some of your output, fraction of output comes back to the system as input, then that is your feedback systems. So that part also coming here. So in open environment, those kind of feedback system is there. So that needs to be understood properly and mathematically to incorporate into the fundamental equations such that we can get the proper like your predictions. Now, when we talk about these fundamental laws in this non-inertial frame and spherical coordinate system, then there will be a like large equations, and we are going to solve that. I am not showing it here, those equations, And those equations are initial and boundary value problem. Those who are in mathematics background or physics, they will understand. So your initial and boundary value, that means you need the initial conditions accurate and also boundary conditions. Now when we talk about initial conditions, so initial conditions means this is across the globe. If you take the different points, maybe a regular grid, you need each and every point your observations. And that is very difficult. Nowhere it is possible. Like your all over the world, only like your those developed countries, they are putting lots of observations, accurate observations, but developing and underdeveloped countries, they cannot. So whatever the data we are getting, so that we are extrapolating using mathematical technique. So when we are extrapolating, there are errors. So that errors are going into initial conditions. So initial conditions, error going, that means error going to the systems, those differential equations, nonlinear equations, and that will be growing that error. So with time, you will get the results also errored. So how to correct it? So you need the proper understanding of physics. Now if you talk about climate change, so let us see here from the different records, like your ice core, or maybe sea urchin, or some other maybe sediment core. So from there, all data available across the globe. So that data, if we plot, then we get this kind of like your variation of temperature. That first one is tectonic scale climate change. That your temperature change you can see. So your first curve, you can see there is a like half cycle type. So your temperature, that your 10-degree variations, and the year from 0 to 10 degree, that your temperature change, that has gone in millions of years, few millions, 300 million years. And if you go to orbital scale climate change, because of Earth's orbit that is changing, and also sun, so your radiations, whatever coming to the sun, and also Earth is getting the radiations not only on the equator, geographical equator somewhere, so your distribution of heat is different. So your that kind of your change, if that is your 10-degree variations sometimes, but there are your lots of variations you can see. So that is also million years, maybe 3 million years. Within that period, lots of changes from maybe 10 degree to maybe 2-3 degree, that changes, fluctuation is there, that variation. Now if you go to deglacial climate change, then you just see in years, like your almost 2 to 3 degree changes, maybe 50,000 years. And after that, your temperature increasing, going towards warm state. And the recent period, like anthropogenic climate change, when human intervention is there, then you have that like your temperature variations that is in the range of 1,000 years. And their changes like in 4000 AD, the temperature you will see how much, and 900 AD, like your now it is coming after that, so temperature change going beyond 1 degree centigrade. So temperature is changing. So nature, actually what is happening in the nature? Nature, this earth, like your long back, for maybe long back, that earth created. That is, that your a billion years ago. Now, that time earth was in different state. Then over the time, sun's radiations and like your different continent, from Pangea to now the whatever the conditions, present conditions, and your Earth's temperature around the Earth, that is your good for us. That means we can survive on Earth. And also in nature, there are different your cycle, starting from hydrological cycle, carbon cycle, sulfur cycle. So all those cycles that has been like your like in a time frame, nature has done that okay, if that much moisture is coming to the atmosphere, it will take few days to come back. And if it is carbon dioxide, carbon cycle, carbon dioxide, it will be coming back to the nature after certain days. But if we add much more carbon dioxide to the environment, then nature will take some time and it will show its abrupt nature. So that means there will be climate change, because something added to the systems as per our that simple X variations that will like your vary the other variables of the systems, and we are showing here as temperature. So that change will be there. So, but like your as morning was discussed, that we should be educated enough such that whatever we are giving to the environment, that should be less, such that like our contribution less. That means your anthropogenic like your this warming will be less. Now these changes and impacts on the earth systems. So this is a complex interactions within the climate system. So this is a well-known like your interaction schematic diagram. So there may be changes in the solar inputs because of sun's its own axis variations. Maybe there some reaction inside the sun changes. Maybe that your sun's constant, that changes. So you will get the radiation at the top of the atmosphere is different. So you will get like your changes in solar radiations. So these complex interaction within the climate systems. Now your earth energy source is the sun. That's what I was all we know. Now both solar, one is solar radiations that is coming, that is short wave radiations passing through the atmosphere. There is clouds, different kinds of clouds. So from there short wave radiation also radiated back. Some part is coming to the earth systems, and earth is absorbing those solar radiations, short wave, and emitting long wave radiations. Some part of that short wave radiations is absorbed by the clouds and some constituents of the air. So that will heat up the atmosphere, and also from the bottom that your long wave radiation that will heat up the atmosphere. So atmosphere is heated up from these two sides. So your those are the heat source to the atmosphere. Now heating and cooling affect the temperature and circulation of the atmosphere. Now this heating and also on the earth, this is spherical, and sun's radiations maximum on the equator. In geography we call geographical equator, but really speaking it is on the thermal equator. So thermal equator, that means where sun's radiation near to the equator is maximum. So and polar regions radiation is very less. So that means nature will try to export the heat from the your tropical region towards the polar regions. That nature is doing, and that we know, like your those who are in physics, they are through mathematics, and those who are in geography, they know that you through the Hadley cell, Ferrel cell, polar cells. So in the meridional directions, that heat transferred by the atmosphere, and in the western boundary currents by the ocean system, that heat is transferred. Now this exchange, atmosphere and ocean exchange heat, water and momentum from the like your water surface. When water evaporated, then you have, it is taking latent heat to the atmosphere, releasing the heat to the atmosphere, then your condensation cools, and then again precipitations. So this process also going on, that means some mass that is going to the systems. Beside that, human intervention also there, like your emission of greenhouse gases, aerosols, and land use, etc., also changes all those parameters. Now your climate sensitivity and feedbacks. So your external forcing is plate tectonics. There are lots of things happening. We don't know that you're underneath the ocean, or maybe between the continental plates. So your lots of changes because of this plate movement is happening. Then changes in Earth's orbit, because lots of your mass from the land system through the precipitations, through the river that is going to the oceans. So your asymmetry created. So your changes of Earth's orbit also getting changed. That is very minute, but getting changed day by day. And changes in sun strength. So your solar radiation change that cause these climate systems and lots of like your interactions. And then you are getting climate variations through the changes in atmosphere. Some people are seeing in the atmosphere that climate change, some people in the ice melting, some are changes in vegetation, then changes in ocean, land, and etc. Now your major climate feedback process, those are water vapor feedback and snow ice albedo feedback, long wave radiation feedback, vegetation climate feedback. So some are positive, out of long wave radiation feedback is negative, and cloud feedback uncertain, like your sometimes may be positive, sometimes may be negative. We don't know in the nature what will happen. Like your model also, how to include it, this is very, very difficult. So in a particular place, we thought that this place maybe your cumulonimbus cloud will form, and its character is like that, its height, cumulonimbus height will be this much, but we never know if there is a long-term flow at the top of the atmosphere at particular level that will carry that and it will put in some other place that kind of cloud. But in the model we are putting it this place. So this is very, very like your difficult things to incorporate into the model. Now your basically this feedback process is like this, like your when your response is amplified by the climate systems, then your called positive feedback, and response reduced by the climate systems we call negative feedback. So I will just go quickly. Like your water feedback is like that, positive increased warming. So if you have initial climate change is like your climate is little bit warming, then it will, water vapor will again increase the warming. So this is positive feedback. Now your snow ice albedo feedback, like your if initial change because of albedo is like your changes, so cooling maybe your where ice is present, so your increased snow and ice, higher reflectivity will be there. So maximum solar radiations will be reflected back. So your absorb of solar radiation is very, very less. So Earth will emit very less radiations. So you have like your greater cooling will be there. So this is also positive feedback. Long wave radiation feedback, that is your negative warmer, like your basically the we use Stephen Boltzmann law of physics to calculate the temperature. Now warmer the global temperature, then your larger outgoing long wave radiations being emitted by the Earth, then your that reduce the net energy heating to the Earth systems, and cools down the global temperature, and this is a negative feedback. Okay. So vegetation, similarly climate feedbacks, that is your, if your albedo and vegetation that will, because of this vegetation change, albedo will be changed. So your initial change, if the climate cooling, then tundra region replaces by forest. So high albedo surface reflects more solar radiations, and your again greater cooling will be there. Similarly, if forest replaces by grassland and with precipitation, if increased precipitation, that will add increased transpiration of water vapor, so it will more water vapor will be added and additional precipitation will be there. So those who are suppose like you're dealing with these vegetations, they know this, but how to include these things accurately in the model. So that's why the interaction with physics, biology, etc. required to improve the model. People are doing in our country also need to come closer to improve the model. And this cloud feedback, as I was telling, sometimes positive and negative. Next, this is your long-term effect, but chemical weathering is another like your feedback process. Although this is long-term, as you know that in the atmosphere you have the carbon dioxide, so precipitation process and weak acid formations, and that will come through rain, and that will there your all the rocks will be exposed, and then chemical attack, then your these will go to the like through the river system to the ocean floor, and this way like your chemical weathering takes place. And this is your negative feedback from chemical weathering that is shown here in the same way. Although this is long term, not the anthropogenic or other, that is your longer time scale. But in longer time scale, this chemical weathering is like your acts as Earth's thermostat, like your chemical weathering. That means it will go to from warmer to colder phase, and nature will automatically will bring from your colder to warmer phase. So this kind of flip-flop will happen. But this is a huge time it will be taken. By that time, maybe like your few hundred generations will not be there. But nature will take its own way. Now you're coming back, like your these two components. This is your atmosphere and oceans. Those are like your very important components of these systems, climate systems. They are your atmosphere and ocean circulations. If it is not there, then your heat will not be transferred. And basically, atmospheric circulations depends on both density, only density variation, but ocean circulations, both wind and density variations. So your wind-driven and your thermohaline circulations, that is important for ocean. And then your ocean circulation also important, because that carries the warmer water towards the pole, such that nature wants to be in equilibrium state. It transports approximately 20% of the latitudinal heat, equator to poles, and transport nutrients and influences weather and climate, so influences commerce. Now similarly, atmospheric circulation also important, because it also, and overall the heating of the earth, if we see that your tropical regions net heat gain is there, and your polar region net heat loss. So nature will try to go towards equilibrium, this heat transfer. So that means heat transfer equation also we consider, considering the first law of thermodynamics in this system. This is done by this kind of circulations that all you know, and you have maybe known this kind of figure. This is your cold currents and warm currents. That is your how like your going from equator to polar regions. And at the same time, thermohaline circulations, that deep water formations, and that deep water is connected with the weather, because if these circulations is cut somewhere, then your weather will change. That means your climate will change. So this is very, very important to understand this kind of your weather system and the circulations of ocean and also atmosphere. This is in record that your change of global temperature that is increasing like anything in the recent period. If you see from 1970 to 2020, temperature is increasing. This is the average global temperature. Now your recent trend, global temperature, if you calculate the trend, that is linearly like going. We expect that this is going linear. But that may not be correct because your model, there your many demerits are there. So if we project or simulate those climate models, that will give some error. And there needs more improvement. Similarly, your global ocean heat content, so that is also increasing. Even in Bay of Bengal, in our study, we have seen that heat content is increasing, and that is enhancing the cyclogenesis region and formation of a cyclone. And we have seen that mostly in this from 1979 to 2015, that analysis shows that in recent time, most serious cyclone like your number is increasing, and that will increase now. This is your sea level. As you all know, morning also discussion was going on, that sea level rise. So all these things, if we want to predict in future, the understanding of geophysical fluid dynamics is required, which is nothing but like rotating stratified fluid dynamics. So that rotating stratified fluid dynamics understanding is required, where like your two things very important. One is your, in case of this geophysical fluid, we should understand the ambient rotations and also stratifications. So these two things very, very important for understanding this geophysical fluid dynamics. Okay, so if we study this, like this through this geophysical fluid dynamics, the like your importance of atmosphere and ocean, its circulations, because of that, like your life sustenance, and also different disaster predictions for societal applications, and also for global climate change that we can predict. Okay. Yeah, sorry. So I'm not going into much details about the mathematical equations here, although I deals with those mathematical equations, but purposefully I have omitted because I don't want to show those big equations and discuss those things. So basically, if we want to understand that atmosphere and ocean dynamics and how temperature will increase, what will be the tropical cyclone speed, etc. So all those equations in the model, whatever like your coupled model, they throughout the world use these equations. That is your that governing equations, continuity equations, that is coming from the basic laws of physics of a system, conservation of mass. And next is equation of conservation of temperature and salt. So equation of conservation of heat, first law of thermodynamics, from there we can get equation of conservation of temperature. And conservation of salt will give you that equations. And then equation of motion and equation of state. Equation of motion will give three, that is coming from the Navier-Stokes equations, starting from the Newton's laws of motion, that your a second law we have learned in class 10, class 12. So that equation applied to these nonlinear systems, and we will get your equation of motions. So equation of motion, three component, x, y, z component, and the other equations we will get. So 7 equations for the atmosphere, 7 equations for the ocean. So we'll 7 variables, U, V, W, rho, P, T, and S. S for salinity, that is your in the ocean, and Q your specific humidity or moisture for the atmosphere. So this is a tricky nonlinear equations that we want to solve, that is in finite difference or finite element method, and initial and boundary conditions we have to provide. That's why throughout the world using this coupled model, both atmosphere and ocean use. And there needs coupler. That means these equations, like your from atmosphere and ocean, how these, like your all these mass energy and momentum transfer takes place. So coupler development. Luckily, I was in the team when I was in Japan, so I developed this kind of coupler for them. So this coupler for this coupled model that is required. Now to solve these equations, you can understand so much of difficult, and at the same time if you consider the different point, like number of grid points, maybe every 1 degree distance throughout the world you will get 360 by 180 multiplied by number of layers, then multiplied by 7. Those equations you have to solve every time. So nobody can do it except your supercomputer. So you're using supercomputer, you have to solve those equations and get. That's why throughout the world coupled modeling, those who are doing, they are like you're doing that kind of simulations, and you're extrapolating it, considering that your future scenario what will be there, carbon dioxide will be doubled. Although we don't know that carbon dioxide, like your emissions in the atmosphere will be doubled or 1.5 or 1.2. So, but we are considering everywhere it will be 1.2. That is also not accurate. But like your, we consider it, and then whatever the result we get, we like your interpret and tell about these things to the society. Now these kind of models, like now I am talking about this atmosphere and ocean. So there are different parameterization schemes. This is your large scale cloud processes, boundary layer processes, dynamics where diffusion takes place, because this is in open environment, diffusion. So diffusion, your first order, second order, its e-folding time, etc. Then gravity wave drag, all are important. But that things we parameterized with the known variable. Like I want the temperature maybe at Kolkata. I have the temperature at Kharagpur and at Kolkata. So can you imagine that in the model we are interpolating that these things maybe by linear interpolations or your cubic spline or whatever. So you are bringing the temperature at Kolkata. So there will be error, because we know that rain, whatever this Kolkata and maybe maybe Kharagpur is happening in between Kolkata. So precipitation may not be there, no precipitation, but this interpolation what it will give. Maybe linear interpolation will give you maybe if the distance is same both sides, then your average of these two will give, which is not accurate. So those kind of many improvements is required, this kind of model. Like your radiation scheme, whatever from the sun's radiations coming, how it is coming to the Earth's surface. We have radiative algorithm, like your different clouds. We don't know that whether there is a cloud, cirrus clouds or mid-level clouds or your lower level clouds and its thickness. So all those things like your parameterization is required. Even like the parameterizations which is done in subtropical regions, in our region not done properly. So that needs to be done also in our regions. So development of climate models. So basically atmospheric model starts at 1970s, and your ocean and sea ice model that starts 1980s. And slowly that development is going on. So there are lots of input. You can see now like your vegetation dynamics model. So that is also added to these systems. So slowly it is improving, and whatever the present generation climate model is giving, in future, like there are huge scope to improve all those points to get the better predictions for future, like your planning for the society. So nowadays we have lots of satellites giving the observations at different points at the same time. So you have initial conditions good. And also you have observations through ocean, atmosphere, like Argo floats, and also different weather stations across the globe. So you have lots of initial conditions. Now you're knowing this satellite remote sensing, we have now like sophisticated computers available across the country. Our Indian government also put HPC at different places. And those HPCs, like you're sitting here, you can also get the access free of cost. And you can do simulations your own, no need that you have to be there. So you can do that. And new technologies like your mathematical techniques and other things coming up day by day. And this physics, mathematics, and chemistry understanding of those, like your variable in that system, that is also improving. And this overall, the observation of climate systems is improving at the, to monitor the climate. And also, if we know the theory of the climate, if we understand the theory of the climate nicely, then our model, whatever the climate model or Earth system models, that will be good. And modeling of climate and predictions, also the like your we can get the diagnostics from those models nicely. And those things we can apply for applications for society and your economical and ecological development. Thank you very much. And if you have any questions. Any questions from the audience?
Since students are present here, researchers are present here, for the last maybe half an hour or more than that, I was watching sir explaining all these things. We who are working in the field of atmospheric and oceanic science, we understand that actually this is difficult when we are talking about atmosphere and ocean. An atmosphere is a very dynamic system. Every moment it is changing, it is taking new characteristics and new features. So the way sir has explained it in a very nice, simple words, in a very lucid way, he has explained all the things, but actually these calculations are not that easy to compute, because those physicists, mathematicians, and chemists, or other background computer science students, multidisciplinary students, those who are working for that, we know that solution, as well as the, as sir has told, we have to do different kind of parameterizations. That is also very important. Approximations which might incorporate, not might, actually they incorporate error. We have to minimize error, we have to take care of the bias. After taking care of all these things, we can do the calculations. So, but in the field of earth science, I can say, sir has explained very nicely, that it is improving a lot. Earlier, the data availability was not very easy, but gradually data is available, primary data, secondary data, and without data, atmospheric scientists, ocean scientists, we cannot work, because we need data for the computational process. And all these things that sir have told, very nicely put together in a very simple language, so that the students, researchers present here, they can understand. So if you have any question, please, sir is here. We are having this opportunity to ask him. You may please ask. Any question? Actually, when I was sitting here, before coming here, I was thinking of a question, because today I'll be getting sir over here. I'll be asking him the question that increased or very frequent number of cyclones. But in due course of time, I saw that sir has already mentioned, that was my question when I was sitting here, because he is a specialist, expert of oceanic science. He is working on ocean atmosphere coupling system. As we know, we are having more frequent and more intense storms these days. And this is a question of, when I go to class also, students do ask me, ma'am, we are getting more cyclones, Amphan and all these cyclones, and this intensity, the scientists are predicting this is going to increase. And sir has already put those things in his lecture, so my question is already answered. So any other question? No? Then, sir, I extend my heartfelt gratitude, sir. You have given your valuable time. You have explained it. And if even later on also, if students are interested, researchers are interested to explore these topics more and more, he is an expert. Later on also, he has always guided us also. We can get his guidance. So with these words, and once again, saying thank you will be minimum or very little to that. But, sir, you have given your time. We are very grateful. Thank you, sir, and for enriching us with all these words and information.
Thank you, Sharadya, for inviting me. Thanks, this Xavier's College. This is the first time I am coming here and seeing this large number of audience, like students, researchers. But I was expecting few questions because then it will be more interesting. But anyway, it's okay, no problem. Beside that, as Sharadya pointed out, that those who are like you're interested to carry out research in these numerical simulations for their clarity, understanding, or whatever may be, you can contact me. And my email address is there or in IIT website, and I will be happy to help. Those who are aspiring for research, so they can also get in touch at IIT Kharagpur. Like we are also looking for very dynamic and enthusiastic research scholars, though those will be dedicated, but obviously they should have background in mathematics. Okay, like here, if we don't get background in mathematics, then IIT Kharagpur with us to carry out research will be difficult. But definitely, if you are doing somewhere research, collaboration is okay, fine. We can collaborate.
Thank you, sir.
Thank you very much.
Thank you, sir.
Yeah.
Thank you so much for coming here. And thank you for your lecture once again. With this, our first session is over. And now I would love, yes, please, MC. Now I will hand it to you.
Thank you, ma'am. As we arrive at the conclusion of this presentation, we would like to take the valued learnings from this session. We are immensely privileged to have gotten the opportunity to hear from our honorable speaker, Dr. Orun Chakraborty. We also take this opportunity to thank the session chair, Dr. Sharodaya De, for having spared her valued time to conduct the session with utmost efficiency and perfection. Thank you, sir and ma'am. Now, I would like to hand over the proceedings to my co-MC, Bhavya.
The speaker for this lecture is Dr. Abhijit Moitro, and the chairperson for the same is Dr. Madhumita Moitro. Sir, ma'am, I'd like to invite you upon the stage. A very good afternoon to our esteemed session speaker, Dr. Abhijit Moitro, respected session chair, Dr. Madhumita Moitro, faculty members, invited guests, conference participants, and fellow students. Barack Obama once said that we are the first generation to witness climate change. and we are the last generation to do something about it. So true. It is in our hands to preserve present and more importantly the future generations of this planet. And for that we need all hands on board. Because there are no passengers on spaceship Earth, all are crew. With that being said, we are honored to have with us Dr. Madhumita Mitra, our esteemed speaker of the current session. Dr. Madhumita Mitra. I'm not the speaker, I'm the chairperson. I'm sorry. Speaker is Dr. Yes, yes. We are honored to have with us Dr. Madhumita Mitra, our esteemed chairperson of the current session. Dr. Madhumita Mitra is an assistant professor of the Department of Microbiology, St. Xavier's College, Autonomous, Kolkata. She did her PhD under the guidance of Professor S.K. Mukherjee, Department of Food Technology and Biochemical Engineering, and Professor S.K. Majumdar, Department of Life Science and Biotechnology, Jadavpur University. She worked as a postdoctoral fellow in the Department of Microbiology, Bose Institute. She is also working as a PhD guide in St. Xavier's College, Kolkata, and as a co-guide enrolled in Vidyasagar University. She has many paper and book chapter publications. She has received the Sir Gangaram Memorial Prize on the paper entitled An Experimental Study on the Production of Intracellular Beta-galactosidase at Different Conditions by Batch Process using Isolated Bacillus cephensis, and Characterization of Synthesized Beta-galactoside by the Institution of Engineers in 2013. I would now request Janvi to felicitate our chairperson. Over to you, ma'am.
Thank you, MC. First of all, I would like to welcome all of you to our college, St. Xavier's College, Kolkata. A very warm welcome to all the esteemed speakers present over here, all the dignitaries, the research scholars, faculty members, and the students, the beloved students for whom we want to share our knowledge, especially the speakers, all the speakers who are here with us. So in our first lecture, we have seen the environment through a physicist's perspectives, how a physicist believes in environment, nature, and how a physics model could help us to save the nature or Mother Earth. It's a great privilege for me to be here to introduce our second speaker of the session, Dr. Abhijit Mitra. Dr. Abhijit Mitra, Associate Professor and former Head, Department of Marine Science, University of Calcutta, has been active in the sphere of oceanography since 1985. A gold medalist in Masters from University of Calcutta, he obtained his PhD degree in 1994. Since then, he joined Calcutta Port Trust and WWF in various capacities to carry out research programs on environmental science, biodiversity conservation, climate change, and carbon sequestration. Presently, Dr. Mitra is serving Techno India University, West Bengal, as the Director of Research. He has to his credit about 667 scientific publications in various national and international repute, and 62 books of postgraduate standards. Dr. Mitra is presently the member of several committees like PACON International, IUCN, SIOS, and has successfully completed about 21 projects on biodiversity loss in fishery sector, coastal pollution, alternative livelihood, climate change, and carbon sequestration. Dr. Abhijit Mitra also is a visiting faculty member and has been invited speaker in several foreign universities of Singapore, Kenya, Oman, and USA. In 2008, Dr. Mitra was invited as visiting fellow at the University of Massachusetts, USA, to deliver a series of lectures on climate change. He has successfully guided about 52 PhD students. Presently, his domain of expertise includes environmental science, mangrove ecology, sustainable aquaculture, alternative livelihood, natural resource management, blue economy, and obviously the changes in the climate which is taking place. So it's a great honor for me to introduce Dr. Abhijit Mitra over here. Sir, I would like to welcome you, and I hand over the mic to him so that he could deliver and he could share his knowledge upon us, and so that we all are getting the ideas from him and the research he has done for so many years. Welcome, sir.
Ma'am, before the lecture starts, I'd like you to felicitate sir.
Yeah, it's here. This is not working. Done.
Switch it on. Switch it on. Switch it on. Switch it on. So give it to me. Switch it on.
ওই আগের পয়েন্টারটা
Where's the remote?
ও
The MCs.
Mic में
আমি ওখানে গিয়ে করতে না আই ক্যান গো দেয়ার অ্যান্ড স্টার্ট দেখুন আপনি চেঞ্জ হলে না এটা না স্যার ওই এইটাতে হবে না আপনার এইটাতে এটা তো এলইডি স্ক্রিনে আপনার আগের একজন স্টুডেন্ট এনেছিল সে আবার চলে গেছে ওকে আই জাস্ট ইন্ডিকেট দে ক্যান চেঞ্জ ইট ফ্রম দেয়ার ওটা আমাকে ওকে মানে আমার সংকেতটা দেখেও চিন্তা করতে পারবে। Give that pointer to me so that he can. Okay. Okay, you take your seat. मेरा symbol देख के तुम लोग change करते जाओ, ठीक है? So very good morning to all of you. Just today I'm going to speak what is the bitterness of climate change and how the bitterness is increasing with the passage of time, and what are the escape routes from getting rid from this event of climate change. Next one. Now, if we see that you know that the greenhouse gases are there in the atmosphere, and carbon dioxide is one of the major greenhouse gas in the atmosphere, and the permissible level of carbon dioxide is 350 ppm. What does it mean? For the student, I again tell that the permissible level or the safe level of carbon dioxide is 350 ppm. That is 350 gram of carbon dioxide should be there in 1 liter of the air. That is the permissible level. But if you just Google in your mobile just now, right at this point at 12:30 or 12:45, you will see that the permissible level has exceeded 415 ppm in many parts of the world. You can see it. It is in your mobile. You go to Mauna Loa Observatory site and you can see it. And Sundarban is no exception to this. Now, why it happens in Sundarban? Please, next one. See, this is one of the important events. The emission is coming from factories, the emission is coming from the industries, and carbon dioxide is the major component of this emission. And when there is emission, you know that carbon dioxide is a heavy gas. It cannot go out, so it stays in the stratosphere and forms a blanket. When it forms a blanket, the shortwave solar radiation which comes and hit the Earth's surface cannot go in the form of a long-wave radiation. A blanket effect is created. And therefore, heat starts increasing, the temperature starts increasing. And that's why the temperature and the carbon dioxide, you can see, they are positively correlated. In the students from commerce, I was talking in the morning, who was just escorting us, they might be known about the correlation. The correlation between the carbon dioxide concentration and the temperature is 0.9835. So this means that it is very near to 1, and the correlation is absolutely very, very positive. So this is one of the major events. The other event is we know that the carbon dioxide is a colorless gas, but suppose we give some potassium crystal violet dye in the carbon dioxide. You see the entire human civilization is surrounded by carbon dioxide, whether it is from the aircraft, from the factories, from the industries, from the offices, from the domestics, everywhere carbon dioxide is there. So, and because of this, the sea level has started increasing. You know, where I am talking about the Sundarban, the sea level rise is 3.15 millimeter to 3.20 millimeter per year, which is much more compared to the world average of 2.55 millimeter per year. So this is a great issue, and the Sundarban is under great crisis. Sundarban, which is just only 200 to 300 kilometers from the place where we are sitting just now in this auditorium. It's just only 300 kilometers. But the Sundarban is under crisis because of the huge carbon dioxide level accumulating over this unique mangrove ecosystem. Why? The first is that Sundarban is a World Heritage Site. You know, it's the only place in the planet where you get the mangrove and the Royal Bengal tiger in a symbiotic relationship. You cannot imagine that anywhere in the world you get such type of cooperation between the tiger, the man-eater, and the jungle. So it is the only place in this planet Earth, and we should be proud of it as a citizen, as a state player of the state of West Bengal. Now the question is that, if you can see the water color of the Sundarban, you see that it is greenish in color in some period, in some seasons. Why? because of the presence of the phytoplankton. You know, the phytoplankton has got a chlorophyll A, and this chlorophyll A is a green pigment. And because of the presence of the phytoplankton, the water is highly productive. And this productivity is reflected by the number of fishes, the diversity of the fishes, because the fishes in Sundarbans consume the phytoplankton. There are more than 250 varieties of fishes in Sundarbans, and whatever fishes you are getting today in the city of Kolkata is from the Sundarbans. But still, I will tell the Sundarban is under crisis, because this is a picture done by one of our scholars, Dr. Sana Ahmed, sitting over here. She has done this study. She has shown that over a period of 3 years, the city of Kolkata, the domestic private car has increased more than 50,000 within 3 years span of time. It started from 6,01,890, and within a span of 3 years, it has crossed 6,51,640. So just see. It is, I am telling about the registered domestic car, like Wagner, Maruti companies, etc. I am telling about the registered. And these cars are emitting huge amount of carbon dioxide. And you know that 1 liter of this diesel, or 1 liter of the diesel is just emitting 2.64 kg of carbon dioxide. 1 liter of petrol is emitting almost 2.392 kg of carbon dioxide per liter. So just now imagine every day how much carbon dioxide is blowing towards Sundarbans. And this is accumulating over the Sundarbans. And not only this one, Sundarban is adjacent to the port-cum-industrial complex of Haldia, Howrah, and all these mega cities. So they are also taking huge amount of carbon dioxide towards the Bengal, towards the Bay of Bengal, because of the wind circulation effect. Now, I'm just showing you a model. This island, it is the biggest island of Sundarban. I think you have heard of this, Sagar Island. It is about 360 kilometer total, and every year, about 15 lakhs people come over here to take the holy bath during the Makar Sankranti in the mid-January, in the Kapil Muni Ashram. Now you see, just 200 years ago, and now you see the picture here, no mangrove, no green patch, only there is a small green patch in the southeastern corner over here. So, which otherwise could be a sink of carbon dioxide. This is not, this has been taken from the satellite. So you see, the satellite does not speak the false things, nor does it reflect. So the sink of carbon dioxide is totally lost. Why? We have mass scale destroyed Sundarban mangrove. We have developed shrimp farms. In Bengali, the shrimp is known as Bagda chingri. Very lucrative, delicious fish, which becomes to marketable size within a period of 3 to 3.5 months. Within a period of 90 days, a small 1 gram fish juvenile becomes 25 gram, and then you get in the market of a price of 600 to 800 rupees INR per kg. So this has destroyed the sink. Otherwise, it would have been covered by the mangroves. And this is a very lucrative business over there. So this is one of the major causes. On the other side, you see the brick lanes emitting a lot of carbon dioxide. This is also a business in Sundarbans, which has proliferated to a mass scale. So these are the major causes why Sundarban is under crisis. And you see how this fish culture, the shrimp culture is taking place. They are drawing the water from the Bay of Bengal estuaries, and now which this pond would have a salinity of 2 to 5 parts per thousand. Now the salinity has goes over more than about 30 PSU, I mean 30 parts per thousand. And therefore, at this particular salinity, none of the paddy grows, the vegetables does not go perfectly. So these are the things. So in Sundarbans, in all the 3 seasons, we have made a study for 3 decades. In all the 3 seasons of the year, it has exceeded, the carbon dioxide has exceeded more than 400 ppm. This is just a record, just just 1 year back, July 23, you see the carbon dioxide from the Mauna Loa Observatory Center was 418.43. And 1 year previous to that, in 2021, it was 416. So 0.56% increase over a period of 1 year. So just after 100 year, you can see 56% rise if this trend continues. So this is really, Sundarban and other parts of the world is in great crisis. This is a supercomputer model project where you see that the carbon dioxide, the reddish in color, the more the carbon dioxide, the color is indicated by the red color. You see that most of the developed countries of the world, like USA, European countries, they are emitting a lot of carbon dioxide. And here comes the question of carbon credit, because I am telling that business has to be linked. A business model should be there, what we are doing in practice in the science. The world is running the business well. So it's not to be stopped over here. There should be a concept of carbon credit. Now I'm telling that how to get rid of this. You know, the solar energy, biomass, wind energy, tidal energy, hydropower, geothermal, these are the non-conventional source of energy which has no emission of carbon dioxide. Many works are done by the IIT Kharagpur consultants regarding the tidal energy. Of course, they are good, but the infrastructure is very, very costly and hard to maintain here in Sundarban because of the siltation, because of other problems over here. Cyclone is frequent, so it is very hard to keep this infrastructure intact. In addition to this, there is also another non-conventional source of energy, which is called OTEC, Ocean Thermal Energy Conversion. Since there is a gradient of the change in the thermal energy between the upper and the lower level of the ocean, there is always a circulation which drives the turbine and converts into electrical energy. So there are scopes, but they are costly for a country like India to sustain. So for India, I will speak of an escape route, which is called the carbon sequestration by the blue carbon. What are blue carbon? They are the coastal vegetations, starting from mangroves, salt marsh grass, seagrass, phytoplankton, they are the coastal vegetations. And this is one of the important concept of the blue carbon. It does not refer to only the organic carbon present in the vegetation, but also in the soil. Now, if you see the blue carbon, you will see that the mangroves constitute a very less percentage, only 0.7%. But if you see per unit area, because they are absorbing carbon not only from the atmosphere, they are also getting the dissolved inorganic carbon from the water. The soil is rich in carbon. Because the mangrove leaves are falling, they are putting the organic carbon there. So per unit area, blue carbon has the highest carbon content in their body. The salt marshes, the salt marshes in our West Bengal coast also, there are salt marshes. You see one of the scholars who will be present here as for poster presentation. We are taking salt marshes at the ground zero level. We are working on it. We are trying to see that how much carbon it is fixing. Also, you see the other, the seagrasses, they are also the important source of the carbon. And also, at the same time, the mangroves, they are also the important sink of the carbon dioxide. So I'm not going in details of all these juggleries and the data, but I'm just coming to the theme so that it can be convinced by you that what actually is the work we are doing. Carbon sequestration means absorbing the carbon inside the plant body, because the plant takes the carbon dioxide for the process of photosynthesis. You have read in class 8, preliminary. Then they absorb it and make it into glucose. Finally, it is converted into starch. This is the main thing. Now, Sundarban is divided into 3 parts. This is the western part, this is the central part, and this is the eastern part. I think this is also not working. You can do it from here. Yes, continue, please. If you see this western part, it is getting the water, fresh water from the Gangotri Glacier. Because when I speak of the climate change, it is not a piecemeal story. It is an integrated story of several ecosystems. See the mountain from the Gangotri Glacier, they are melting the ice and coming to the Bay of Bengal. So this area is hyposaline, salinity is less because the fresh water is mixing over here. But if you go to the central Indian Sundarbans, you will not get any freshwater flow from the upland. Again, you come to eastern part, to our neighboring country, Bangladesh, the fresh water is coming through creeks and estuaries of the Padma River. So these are the main important things. The western sector is hyposaline, less saline. The central sector is hypersaline. And the eastern sector is again hyposaline. We have made a study for the last 30 years. And this is actually the western sector, this is the central sector, this is the eastern sector. A model has been developed where you can see that with a database of 9,200 readings, we have got a bell-shaped curve where western sector is low saline, central sector is hypersaline, and eastern sector is again hyposaline in nature. We have developed a startup manual with CSIR. A project is still going on where we have taught the students that how to measure the carbon stored in the tree. Now this is our ground level work. We go to the forest with our scholars and students, some of whom are sitting over here. Then we measure that what is the volume of the tree. How we consider the tree as a cylinder. You know that the volume of the cylinder is pi r square h. Then we multiplied the cylinder volume with the density of the wood. It becomes a mass. When it becomes a mass, volume multiplied by density is the biomass, then we put that small piece of wood into CHN analyzer, we get the percentage of the carbon. That's how we measure that each and every species, how much carbon is stored. So this is the quadrant, 10 meter into 10 meter. We calculate how many trees are there of each species inside the quadrant. And this is how we are measuring. Pi r square h, I have told. You have told, multiplied by wood density, you get the stem biomass in kg. And this is the piece of wood we are tracking there and putting it into densitometer to know the density of the tree. And that's how it works. Then we take the piece of wood into the CHN analyzer, and we get the data from the forest department that what is the age, and then in how many years this carbon has been stored. That is called carbon sequestration. Carbon sequestration and storage is not the same. Sequestration is storage by time. So that is very important. So you see, this is a collection from the ground zero level where we are collecting trees of 1 year from the nursery. And after that, this is the nursery picture from where we get the different species of the trees. Then we bring them to the Kolkata through the boat from the heart of the Sundarban, which is a very, very thrilling and interesting experience. Then after that, it is being taken from the boat, and then we get a government facility also. The Konnagar municipality has supported us with the transportation and doing everything. They are very interested. And then we take that piece of wood to the CHN analyzer, to TIFR and other lab, where we get the percentage of the carbon. And that's how we know the carbon percentage. These are some of the pictures, Agiceras. These are, I'm not going in details, but how much carbon is stored in each and every species, that is very important. Then next. Then, okay, go on skipping, yes. Next one. So this is how we are doing it, and with this data we go for a regression equation analysis, and these are the different parts. You know, when the regression equation, the R square value is very less than 0.5, there is no significant relationship. So the total carbon of the leaf biomass does not have any significant relationship, obviously because the leaves fall down and they do not store the carbon permanently. But compared to the stem and the total biomass, they remain in the nature. So stem biomass, you see, it's 0.64. That means it's giving a very good. Again, root is not giving. Again, you see the total carbon in another species. So this is how we are doing the modeling. And finally, these are the results of the different species. Now, if you see this, you will see that the stem biomass is having a very good relationship with the total carbon, but even the total biomass, the value is 0.99. If you go for the model, the stem biomass and the total biomass. But leaf and root biomass does not have any relationship. So if anybody wants to know about the carbon content, they can go for the stem biomass or for the total biomass, but the root and the leaf are not giving the exact picture. Now these are the softwares and the algorithm developed where you can put the value of the value of density of the tree, the height of the tree, and then automatically you will get the stored carbon and the sequestered carbon. Now, if you multiply the carbon with 3.67 factor, you get the carbon dioxide. Why I'm telling? Before that, I told about the stored carbon, but stored carbon does not give a financial value. You know, 1 ton of carbon dioxide, I am telling, 1 ton of carbon dioxide cost in the world market, in the share market, $19 to $20. Sometimes it goes high and low, just like the share market. Sometimes it becomes $60, but not the stored carbon, the carbon dioxide. So the stored carbon has to be converted into carbon dioxide by multiplying with 3.67. You divide the atomic molecular weight of carbon dioxide, 44 by 12, the atomic weight of carbon, you get the factor 3.67. And then you see that, the carbon credit comes. I have told you that developing nations, they are polluting the world. And we are planting trees to absorb that carbon dioxide. So they have to pay us. This is called the carbon credit. Carbon credit comes under, not only under the biology or the physics or the other sciences. It is very much related with the commerce background also. The credit, how much money we are getting for the plantation project, and this has been supported by the United Nations organization. In the last Geneva conference, I was there as one of the signatory. So this is very, very important. And then the auction is made. So this is very important. In West Bengal, you know, we have calculated throughout the entire West Bengal, not in Sundarbans. It is having 0.1 billion tons of carbon, which is multiplied with 3.67, which comes to 0.4 billion tons of carbon dioxide. Now, if you want to know the price, you know, it is $7 billion carbon dioxide is present in the mangrove forest of West Bengal. $7 billion. This is the World Bank figure. And it can be improved in any way. So the last thing is that we should be very much active. And another important thing is that you see the CO2 level in the city of Kolkata, how it is increasing. But suddenly there is a decrease you can see over there. Why this decrease is there? Because the decrease is because of the COVID-19 lockdown phase. During this lockdown phase, there was complete paralysis of the transportation system, the agricultural activities, the industrial activities. So the carbon dioxide has come almost to 250 ppm. I saw some of the papers in the abstract volume. I appreciate that. So this carbon dioxide, this is another important issue. This carbon dioxide, when reacts with water, forms the carbonic acid, and the water becomes acidic. This is called acidification. When the water becomes acidic, this mollusk, they starts dissolving and they cannot unite. So the mollusk starts dying and dying. And this picture has been generated by two of our graduate students, Srija Ghosh and Deepayan, who are present over here. They have done a wonderful job. They have taken the data of the western, central, and eastern Indian Sundarbans, and they have seen that in the eastern Indian Sundarban, the pH is high compared to the western and central. Now, why this is so? Not only in 2002, it has been also seen in 2012, the same picture. This also seen in 2022, the same picture. The eastern sector is having a more pH. The reason is that the vegetation has not been touched in the eastern sector because of the strictness of the forest department. There, you cannot enter the eastern sector without the permission of the forest department. So, more the vegetation means they are absorbing the carbon dioxide from the water. And that's why the pH is not going down, because the carbon dioxide, which would have otherwise lowered the pH, they are going inside the trees. And that's why the pH is not going down. And this is and therefore we find that in the eastern sector, you see in the stations like Arbeshi, Jhila, Harinbhanga, they are in the core area where the tiger stays. The pH is increasing with the passage of time. You see the bar, and you can see that the eastern sector is much a safer area compared to the western and the central sector. The phenomenon is that there is a combination of biochemistry, physics, chemistry, and interdisciplinary science, economics, and commerce. Because this is the biochemistry. Rubisco, ribulase 1,5-biphosphate carboxylase oxygenase, is the main enzyme which binds the carbon dioxide. More is the vegetation, more is the Rubisco enzyme, and they bind the carbon dioxide in their active sites, and that's why the pH does not go down. This is very important. So we should save the mangroves. At the end, I will tell it. And there are certain publications you can go in the Google, and you can Google it, and you can get these books. Almost they are costly, but you can get these books up to 100 pages free of cost to read if you are interested. And then there are certain innovative livelihoods by which we can reduce also. You know that this is a yogurt which is prepared from the fruit of a mangrove vegetation, which is called Sonericia cassiolaris. They are rich in vitamin C. Dr. Prosenjit Pramanik is there. Please stand up, Prosenjit. He is the fellow doing postdoc in Techno India University, and he is now going for a patent. Let us give applause for Prosenjit, so that he has done a wonderful job. And this is the thing. We should take the science to the door of the industrialists so that we can earn something, so that the money rolls and the benefit of the science reaches to the various sectors of the society. So next one is that this is also another product made rich in vitamin C, biscuits and cookies. And this is also bread from the seaweed. It does not look good, not marketable, as if it is being attacked by fungus, but they are rich in antioxidant like astaxanthin. They are made from the seaweeds like ulva and enteromorpha. And this is the oyster. You know, oyster plate is very, very delicious when you go in a 5-star hotel. But these oysters are gradually dissolving. And this oyster culture can be done in Sundarban because the calcium carbonate of the oyster shell, they also absorb the carbon, a substantial amount of carbon. Some of our scholars, Dr. Shampa Mitra, she has done a work in the Goa coast, in the Andhra Pradesh coast, in the Vizag coast. We have seen that these oysters are accumulating substantial amount of carbon in them. So the carbon sequestration is not only by the animals and the plants, they are also can be converted in our active livelihood programs. Now, coming to the next, we have to switch from here. Now, this is actually, as I have told, the blue economy. With this, I am ending. It is coming very soon on 22nd of September. If you make a Google blue economy in Indian Sundarbans, exploring livelihood opportunities, published by Springer, you will see that how the business model and the scientific things are fitted with each other, so that we can go for a newer dimension of the economy, where the resources will come with a net zero emission of carbon. Resource will come for the benefit of the human civilization in the coming future. With this, I thank all of you. Thank you very much.
Thank you, Dr. Abhijit Mitra, for your so much of data and the knowledge that he has given us. We all, I think, many people here, sitting over here, we have visited Sundarban, but we never thought of all these things. Today, he has given a very detailed knowledge about the different sectors of Sundarban, which is there, which is more saline, which is less saline, and why it is so. And the most important thing is, he has provided us the knowledge to the basal level, where he has shown that how the livelihood could be developed. So this is the basis of the research. We are doing research not to publish the papers. We are doing research to put it down to the fields, to be available to the common people. And that's very much appreciable, I think. Thank you. Thank you, Dr. Mitra.
Thank you. Thank you.
The session is open. If you have any questions, you are welcome. He is there. He will answer you.
Yeah, please, please. Yeah, we have got two business models. One is that done by Dr. Pritam Mukherjee and Sana Ahmed. They have developed a business model where they have told, you see, some of the pharmaceutical products obtained from the medicinal plants of Sundarbans, they actually, this Calcutta-based pharmaceutical companies are getting them. They are just extracting. So they have developed a reverse business model where they are telling that that companies like Dabur and others, I am not naming them, they should set their own plants right in the heart of Sundarbans so that the people get involved right from culturing those plants, farming those plants. They should know the process of operating them, the process of extraction of those chemical compounds, and that should be sellable in the market. They have developed some business model, and the other business model we'll be discussing on with the Principal Secretary of Forest Department on this 30th of August, just after 2 days. And they are very interested because already 20 SIG are acting over there in Sundarban under the FPC, Forest Protection Committee. So these are the two ways. Thank you very much. Right. It has to be grown there only and involving the local people only. So that they get the benefit. Otherwise, if they don't get the profit, they will not show that interest. They will again start going inside the forest, collecting honey and fighting with the tigers, poaching, etc. Thank you. Any other questions? Yeah, please.
Take the profit out of here, but that does not take the responsibility to e-waste management. It is produce much carbon in our environment. I am from National Library, Saurendranath Dotto. I am working as a UN volunteer for the environment.
Thank you, Mr. Datta, for your question. E-waste is certainly a very, very hazardous one. It is not only emitting the carbon dioxide, but at the same time emitting the radioactive alpha, beta, and the gamma particles, which is very, very dangerous. So in that case, what is done, there is an innovative concept, but I don't think that whether this concept works or not. I have read in some of the books, I'm just telling you the concept. The e-waste should be sealed in a lead container lab. Lead container lab, I will tell that it's a type of box, and then it will be suited to the atmosphere so that just like the planet, they will start revolving and revolving. So that is also very dangerous, because if that any collision occurs, then again there will be a radioactive fallout. So this is one of the things. The other is that they are planning to put it dumping under the ocean in the Hadal zone. That also will not work, I think, because in the Hadal zone there is a question of sub-oceanic volcanoes which can melt at the temperature the lead container also. So ultimately this is dangerous, but some of them are working by making some statues from the e-waste, some of the companies. I don't think whether it works or not, but at the present moment, this is not actually my domain area. It's not my domain area. So I was telling that if there is an emission of carbon, the only thing is that you go for an alternative livelihood or for the vegetation-based carbon sequestration.
Producing that one. Company take out their profit. I asked government of India to pack up the thing in a ship and send that country of origin so that they will face the pressure of controlling of their carbon emission.
Yeah, if of course the United Nations representative is here, it's an international issue. So if they
Yes,
put
it's
pressure on that
international issues.
developing nations, it can be done.
Okay, thank you.
Thank you.
Any more questions from anyone?
Oh, there is still some questions.
As you mentioned, blue carbon dioxide. So please explain blue carbon dioxide and how it's formed.
Okay. I think you have read in the secondary level what is coal. Coal is black carbon. Whether it is a bituminous coal or lignite coal or any other varieties of coal. But blue carbon is basically the coastal vegetation. Why they are called blue carbon? Because they are absorbing carbon dioxide for the purpose of photosynthesis and then making the glucose inside their body, and after emitting one molecule of water, they are making starch. This starch is formed from the blue ocean. Not only from the blue ocean, from the oceans, bays, estuaries, rivers, etc. So the carbon dioxide is coming from the blue environment inside their body. Not that the color is blue. Since they're coming from the blue environment, which is constituting 71% of the Earth's surface, so that carbon is called the blue carbon. Basically, the carbon within the coastal vegetation, the carbon within the mangroves, the carbon within the salt marsh, the carbon within the mollusk, the carbon within the sea grasses, they are called the blue carbon. But now the scientists are telling that these leaves of these plants, they are also falling down in the soil, they are decomposing, and that soil is also blue carbon. So blue carbon are basically the carbon stored in the coastal environment and also in the offshore and inshore environment, in the vegetation as well as in the soil. Any other question?
Anyone with any question?
So I am from the sociology department,
Okay.
and the excellent data that you shared, I think is very limited to the academic world. But for it to have a larger impact on society, the common people need to be sensitized. So is there any plan set for that to happen?
Yes, sensitization and awareness program is a continuous process, and we will be meeting with the Principal Secretary of the Forest after 2 days, where we will propose, and awareness is being generated because in Sundarban people are aware that they have got a beautiful natural resources, but out of hunger is greater than awareness, hunger is greater than the knowledge. So they are going into the forest, cutting the woods for getting timber, honey, wax, fish, illegal fishery they are doing, illegal poaching they are doing. So awareness is one of the bridge, but at the same time awareness should be coupled with business model so that they can get some profit. So that we are trying to do. Thank you. So I think,
Yeah.
is there any other question?
We feel no more questions, but it's very good. It was very interactive session. We got so many questions, and I hope all of you are satisfied with your queries. Thank you very much, sir, for your deliverables.
Thank you. Thank you.
Thank you.
This marks the end for the lecture. Hope this brought new insights and inspired you to take a positive action to heal the world and make it a better place. I would like to thank the speaker of this session, Dr. Abhijit Mitro, and his words that have sowed the seeds for a cleaner and a greener future. I would also like to thank our session chair, Dr. Madhumita Moitri, for conducting this event with excellent efficiency and grace. Before concluding this event, I would like to call upon Mr. Nandan Lal, the owner of Hula Deck Recycling. Mr. Nandan Lal has immensely helped us, and more importantly, has immensely helped the planet, because he has decided that he will recycle all the plastic water bottles used in this event. Sir, I would like to call upon you and maybe have a few words.
Hi guys, good afternoon. Hi, good afternoon. I know lunch is a little far, but if I can have a little bit of energy, right? Hi guys, good afternoon. Thank you. Yes, so being a Xaverian myself, I've given a lot of speeches on this very stage and this podium, participated in a lot of fests like we are having one today. So feels good to be back, as a guest speaker, if I may say so. So we are here today to, speak about waste management. So our company, Hula Deck Recycling, we are into electronic and plastic waste management. Can we remove that standee? It will block the video. If you can put it in front of that podium, it will be better. Yeah, perfect. Thank you. So we are into electronic and plastic waste management, as we rightly said. So we are your recycling partners for this event. I have a short video presentation. There was a wonderful question by Sir on e-waste management. Is that Sir still here, or has he left? Oh, I would have loved to answer some of his queries and what is happening in India about e-waste management. I have a small video for you which explains the entire process because of the time that I've been allotted. I think it's best that let the video speak for me, and post which I'll be happy to take any questions or any queries that you may have, right? So yes, please.
India generated over 771,000 tons of e-waste in 2018 and 19. Next year, the figure rose 32% to 1.14 million tons. Fast forward a year ahead, and India is now officially the world's third largest e-waste generator, producing over 3.23 million metric tons of e-waste per year. Jamshedpur, or Tata Nagar, was India's first planned industrial city and continues to be an industrial hub. It is a city amenable to new rules and regulations that improve public services. It takes pride in being a trendsetter in this regard. So the city administration decided to take the initiative to deal with their e-waste in a better manner. Let us understand how the authorities manage Jamshedpur's e-waste and why awareness about the matter is equally important. A city built around the century-old Tata steel industry, Jamshedpur generates half a ton of e-waste per day. Before 2018, hundreds of local kabadiwalas and recyclers used to collect e-waste and burn it to extract valuable metals from it. During the process, they would expose themselves and the environment to toxic fumes and chemicals. This was an unsustainable situation.
यहाँ के लोग काफ़ी स्वच्छता को लेकर के और सफाई को लेकर के काफ़ी सजग हैं, क्योंकि आप जानते हैं कि जब टाटा जी ने इसका इस्टेब्लिशमेंट किया था तब से लेकर के आज तक लोगों के अवेयरनेस में काफ़ी बढ़ोतरी हुई है। और ख़ास करके ई वेस्ट जो है एक नया चीज़ हम लोगों के द्वारा ई वेस्ट कलेक्शन सेंटर बनाया गया है, जो कि हम लोगों ने करीब 4 साल पहले इसकी जो है आगाज़ किया था। और इसको हम लोग जो है रिसाइकलिंग के लिए हम लोग कलकत्ता भेजते हैं, बेंगलोर भेजते हैं, और हम लोगों ने एक कंपनी हायर किया है। हुला डेक के माध्यम से हम जो भी ई वेस्ट कलेक्शन यहाँ पे निकलता है उसको हम लोग कलेक्शन करते हैं, प्रोसेस करते हैं, और फिर उसको रिसाइकलिंग करके हम लोग पुनः फिर उसको यूज करवाने के लिए मार्केट में लाते हैं।
On June 5th, 2019, after getting a go-ahead from the State Pollution Control Board and completing logistical formalities, Hula Deck started its full-fledged operation in Jamshedpur at a warehouse allotted by Jamshedpur Utility Service Company, JUSCO.
We are an electronic and electrical waste management producer responsibility organization. Our job is to collect electronic and electrical waste from across the country and channelize it to recyclers of the same on behalf of producers. We have about 50 odd producers working with us right now and 10 recyclers across the country. So this entire process of collection and channelization to the recycler as per the law is done on behalf of the producers. Now who are the producers? Producers are essentially the brand owners or manufacturers of electronics who are selling new electronics in the market. So as per the rule, it is their responsibility to ensure that when they sell products, when that product becomes end of life or becomes e-waste, it needs to be properly collected and recycled. Common brands such as smartphone brands or consumer durable brands are responsible for this, and they fund organizations like ourselves to do this on their behalf. This center also is run for many of one such brands that we work with.
The staff of the E-Waste Management Center at Birupa Road collects e-waste in 4 ways. Monthly door-to-door collection is carried out by 2 dedicated hula-deck e-rickshaws, each of them accompanied by 2 staff members for collection and for raising awareness about safe e-waste practices. Apart from this, about 80 vehicles that belong to the city administration also collect e-waste in a segregated manner while collecting other wastes. During the awareness campaign, many institutes became interested in the cause of managing e-waste better and agreed to work as local drop-off points for e-waste, where people associated with them could deposit their e-waste. There are 5 such e-waste collection centers in Jamshedpur. The largest quantity of e-waste comes from bulk waste generators. The list of bulk waste generators in Jamshedpur is long and it contains names not limited to the Tata Group of companies. A toll-free number has also been provided where citizens can reach out to schedule a pickup of e-waste.
हम लोग पास 2 सालों से जुस्को के साथ में जमशेदपुर में काम कर रहे हैं। बेसिकली ई वेस्ट की अलग अलग कैटेगरीज होती है। सबसे पहले आता है आईटी इक्विपमेंट्स। आईटी में आपके आते हैं प्रिंटर्स, कंप्यूटर्स, सीपीयूज। उसके बाद आता है कंज्यूमर इलेक्ट्रॉनिक्स, जिसमें आपके घर के सामान हो गए, एसी हो गया, फ्रिज हो गया। तीसरा आता है इंडस्ट्रियल आइटम्स। इंडस्ट्रियल आइटम्स में जैसे आपने देखा होगा लाइट फिटिंग्स जितनी इंडस्ट्रीज़ में लगी होती है, उसके अलावा कंप्रेसर्स होते हैं। एक और कैटेगरी होती है बैटरी के। तो बैटरी में 2 टाइप होता है, लेड एसिड और जो ड्राई सेल होता है, तो वो भी हम लोग लेते हैं और रिसाइकिल करते हैं। ई वेस्ट में प्रॉब्लम सबसे ज़्यादा ये आती है कि लोगों को पता नहीं है कि ये हज़ार्डस है कि नहीं। बेसिकली कोई भी इलेक्ट्रॉनिक चीज़ जो होती है उसमें कुछ ना कुछ हज़ार्डस होता है, जैसे मरकरी होता है, कैडमियम होता है, लेड होता है, तो वो आपके एनवायरनमेंट को हार्म कर सकती है। सपोज़ एक अगर सीआरटी जो बॉक्स वाला टीवी होता है उसमें लेड होता है, तो अगर आप एक लोकल वेंडर को उसको देते हो तो वो उसको सेग्रीगेट करके जो प्रेशियस आइटम है वो निकाल लेता है, बट जो लेड होता है उसको वो बाहर फेंक देता है, जिससे सॉइल, वाटर पोल्यूशन और एयर पोल्यूशन हो सकता है। हमारी जैसी कंपनीज उसको एक अच्छे तरीके से रिसाइकलिंग करती है जिसमें एनवायरनमेंट को डैमेज नहीं होता है।
Overall, 230 tons of e-waste has been collected till date, 95.5 tons in 2021 alone. The E-Waste Management Center has a capacity of 35 tons. Once enough waste has been accumulated at the center, it is transported to the Kolkata warehouse of Huladeck that has a capacity of 160 tons. In general, the transfer of waste from Jamshedpur to the Kolkata warehouse takes place once a month. The story of e-waste does not end here. After transportation to the warehouse, Huladeck sends the e-waste to 6 recyclers authorized by the Central Pollution Control Board. We met one of these recyclers to understand how each item of waste is carefully broken down into its parts. Just Dispose Private Limited is a recycler operating from Vasai, near Mumbai. Just Dispose is a single point of contact for meeting all obligations under EPR laws as per CPCB. With a strong collection system, a reverse logistics mechanism, an in-house recycling facility to recycle e-waste, plastic waste, precious metal recovery, and a robust reporting system for documentation, the company ensures scientific processing and disposal of waste.
India is a developing country and we have a very good population. So the potential of this e-waste generation is much higher. whatever generation of gold production, out of that 30-40% of gold is used in electronics item, gold, silver, whether any precious metal. So we can recover that precious metal back. All these metals has its own value. Along with that, some hazardous materials are also there in the electronics. Some chemicals are there used at the time of manufacturing it. So that is also to be channelized and properly dispose it of. Otherwise, it's dangerous for human health. So when we bring material to our facilities, so we wait, we make a record, then we segregate it in a commodity wise. Suppose whether it is a IT equipment, whether it is white goods or not. Then we check that whether this material can be reused or not. If material is not usable, non-repairable, then we do recycling.
At the Just Dispose plant, an electronic item is first manually dismantled and segregated according to the type of elements they are composed of. Generally, parts are divided into ferrous metals, non-ferrous metals, and plastics. There are separate sections to process and recycle these after they are segregated. For example, plastics are shredded and mixed to be sold to different manufacturers and used as alternative fuel in cement factories. Copper is separated and stripped into wires. One of the most intricate processes is extracting thin copper wires from printed circuit boards that are found in computers. The copper is converted into ingots for reuse, while fiber boards they were embedded on are used in tile manufacturing. There are separate machines to recover precious metals like gold and silver, which are eventually sold. Jamshedpur authorities have understood their target audience and focused on institutions like schools, industrial units, the Chamber of Commerce, etc. to good effect. Jamshedpur Utility Service Company's tie-up with Huladec has been beneficial to both the entities and ensures that the city's e-waste is collected and recycled in a smooth and efficient manner. Involvement of producer responsibility organizations in the management of e-waste is an easily replicable practice, as it comes at zero cost to urban local bodies while ensuring adherence to the e-waste management rules of 2016.
अभी हम लोग को फ्यूचर में और भी प्लान है कि ई वेस्ट कलेक्शन सेंटर को डिसेंट्रलाइज तरीके से और भी करीब 5 से 7 सेंटर और भी बनाने की योजना है और लोगों को घर तक ही हम लोग सोच रहे हैं कि उसके लोकेलिटी में ही हम लोग ये चीज़ सेंटर प्रोवाइड करें ताकि लोगों को इतना दूर आने की आवश्यकता नहीं पड़ेगी.
So one more thing as an industry that I think everyone will agree with me we are very proud of is the fact that we've managed to change consumer behavior towards habits of recycling. The EPR model or the producers being involved actually made the business and the overall environment quite sustainable.
Okay, so that was a video we made for Niti Aayog. Mr. Amitabh Kant had. Okay, thank you. Yes, so that is a video we made for Niti Aayog. Jamshedpur is one of our 23 cities where we operate in. Of course, we started off from Kolkata. We are one of the first pan-India Kolkata-based waste management brands. So that's something I'm quite proud of. In fact, just for you guys, of why events like this are important, because Huladec was actually born in this auditorium. We used to have a business plan competition back in the day when I used to study here, and I presented the concept of e-waste management in Huladec for the first time in St. Xavier's, and that's how it grew, and that's where we are today. So if you have dreams, So if you have dreams, please follow them, and I'm sure, as they say, nihil ultra, right? So I'll be happy to take questions if there are any from anyone. Yes, please pass the mic. We'll do it as quickly as possible. Yes, sir. I think there's a student behind you who wants a question, then we can start, right? Anyone else? Okay, say it. Yeah.
Are there any incentives that you provide, like plan to provide or something like that, so that people actually participate in it?
Beautiful question. Okay. So, just to show you the growth of how consumer behavior changed, like I said in the end of the video, that we are proud that we managed to change consumer behavior towards habits of recycling. In the first year of incorporation, Hulatek had collected and recycled 35 metric tons of e-waste, right? Last year, we did 3,850 tons in a matter of 7 years. So from 35 tons of collection in the first year to 3,850 tons. That's almost more than 100 times growth in 7 years. So it has majorly happened because the consumer's mindset changed. How did we make that happen? First, of course, we have a lot of brands who are sustainable or support sustainability. More than 35 to 40 brands we have who offer discounts and vouchers on their products and services if you decide to recycle your e-waste with us. A very popular name in this might be something, if you might have heard of, like P-Safe, right? It's a hygiene brand that we work with. It's quite big now, right? So P-Safe has been with us since the beginning, where they offer discounts on their products if you recycle your e-waste with us. If next time you're in chai break, go use the code Hulatek, you get 200 rupees off on on your food and beverages, right? So these are a few tie-ups that we have, incentives that we've created, where people can actually use the benefits out of recycling in their day-to-day lives. Secondly, of course, awareness creation, something that we do, like we are doing here today. We've really managed to convince people and tell them what the harms are of unauthorized recycling and how the country as a whole can benefit. So much so that in 2016, the recycling rate was 1% in the globe, in India. Total e-waste generated ka 1% recycle hota tha, which was 1.2 million tons. Currently, it is at 5% of 3.2 million tons. So you see that's almost a 15 times growth in the last 5 years, mainly because consumers have changed their mindset and they are deciding to recycle versus throwing it away. Yes, sir. Right, sir. Correct, sir. No, they are, sir. So we work as a PRO, a producer responsibility organization. What the mandate is that whatever material they have sold in the market, after the average life of the product gets over, they have to recycle a certain percentage of that. They outsource that job to us. Our job is to spread awareness, to make collection centers and collect that material and channelize to recyclers like you just saw in the video. So sir, you'll be happy to know that out of the 1800 odd registered producers, more than 85% have met their collection targets last year.
But I view that most of the product coming from outside India.
Right. No, sir, that's absolutely untrue, sir. Because see, e-waste import was banned in 2017. Right. Yes, there are some illegal imports happen, but a sizable number has fallen after 2017.
In spite of that, it has been shown, found different marketed, that is, e-waste has repeatedly sold and sold and sold.
No, e-waste is sold, sir. We do not disagree. We are ourselves saying that only 5% of e-waste gets recycled.
Which can be recycled or reused, that should be.
No, true, sir. Of course, what can be reused should be reused, because we always learn that if you can extend the life of the product before recycling it, of course you should extend the life of the product. Nothing wrong with that. So we understand that only 5% of the material gets recycled properly. Yes, so 95% is still in the open market. But the global recycling standard is 30%, sir, where countries like Switzerland and Germany do 50%. Right.
You see that most of the product goes to the African countries.
No, untrue, sir. India has a very robust, if I may say so, a very robust kabadiwala system. So we don't need to export our waste to Africa.
All over world they are sending big companies sending their e-waste to the African country. They are facing the carbon footprint.
Thank you, sir. Thank you for the discussion. We can continue in the lunchtime because we are running late. Sorry, sir. So we can discuss.
Yeah,
during
any other
lunchtime.
questions?
So I don't think any other questions are there. We can, sir, always discuss. This is a very important issue. We should take it up seriously because recycling of plastic waste is so important. And thank you very much for this presentation. And many of the students have been actually knowing this thing, and hula deck will be popular in no time. Congratulations. So we will break for lunch now. We will continue sharp at 2:15. The lunch will be served from the big parlor. Thank you.